So good morning everyone. In this video, I'm going to show you how to prove formulas using the principles of mathematical induction. So basically, mathematical induction is a very simple way on how to prove many formulas or many statements all over the world. And mathematical induction is one of the four ways on how to prove a statement. I mean, to prove formulas or statements using PMI or principles of mathematical induction, just follow these steps. Steps. First, the basis step. So what is the basis step? So you need to show that a formula is true for n equals 1. Second, inductive hypothesis, which in this step, you're gonna make an assumption. I mean, show true for n equals k. And third step, inductive step, is that you're gonna show true for n equals k plus 1 in order to conclude that by using PMI, we prove a certain statement. So, in order to understand this topic more, let me give you an example or some examples of statements that can be proved using PMI. So, first example, so we have prove 1 plus 3 plus 5 plus dot 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 plus 2n minus 1 equals n squared is true for all positive integers. I mean, this z to the power of positive sign, this is called positive integers, or we could also make this as natural numbers because they are the same. To prove this, so show true for n equals 1. So, first, in order to prove, we'll get this one, this n term here, and this one. And we was gonna substitute one and see if they are equal. And if they are, we could proceed to the next step. So 2 times 1 plus 1 equals 1 squared, right? Substituting n equals 1. We have 2 times 1 is 2 minus 1 equals 1. 1 squared is 1, right? So now 2 minus 1 is 1, and we prove that they are equal. So n equals 1 is true. Let's try for n equals k. So nothing to worry about n equals k because you're just gonna substitute n by k, and there is no extra solution. Just substitute. So 1 plus 3 plus 5 plus dot plus 2n minus 1 equals n squared. So we have substituting this by k. So we have 1 plus 3 plus 5 plus dot plus 2. And now n times k minus 1 equals k squared. So this is the k. So n equals k is true. This is an assumption. Now, this is the last part in proving a statement using mathematical induction. So we're gonna prove n equals k plus 1 is true. Now, to do that, first let's rewrite this expression. Let's copy this expression to k minus 1 equals k squared. And to solve for k plus 1, before you substitute n or k by k plus 1, let's make this left side equal to this. But how? Go back to your assumption that you make in the inductive hypothesis, which is n equals k. So as you can see, right, this whole thing is equals to k squared. So we're gonna substitute this one by k squared. And you may be thought that they are already equal. No, there's still a step. Now, k squared. And in order to substitute k by k squared, simply, at the left hand side, you'll just need to copy this, and this one, this 2k minus 1, the k here, you should substitute the k here by k plus 1. So that's how you gonna do that. So bracket 2 times k plus 1 minus 1 equals this k squared at the right hand side. So all of the k at the right hand side, you'll just need to substitute them by k plus 1. You have k, so you have k plus 1 squared, right? So that's it. So this one, so I mean, we could solve this in two ways. It's either we, we will gonna expand both of the sides, or we're gonna make, I mean, we're gonna condense this into this form. So let's see. So first, 2 times k plus 1, we could solve that by using distributive property. So plus 2k plus 2, right? So because 2 times k is 2k, and positive 1 times 2 is plus 2. So that's it. 2k plus 2 minus 1 equals to k plus 1 squared, right? Now, simplifying this one, so we have k squared plus 2k plus 2. 2 minus 1 is positive 1. You have 2k plus 1 equals 2k plus 1 squared. And now, we could condense this into this form because this is a perfect square trinomial. So we could transform that into square of binomial, which is this, by getting the square root and the square root of this one. So k squared, the square root of k squared is k, and then 1, you have plus squared. You have k plus 1 squared, right? And since they are both equal, we can conclude that therefore the statement above, which is this 1 plus 3 plus 5 plus dot plus 2n minus 1 equals n squared, is true for all positive integers. So that's it. So that's the first example. So that's it for this video, and in the next video I'm gonna make another example about this problem involving mathematical induction. See you in my next video. Bye bye.